We are in the BI platform studio, and I'm speaking with Mike Ferguson, independent analyst and founder of Intelligent Business Strategies. Mike, you did a session during our data warehousing and BI conference. The topic of this interview will be data observability. Mike, can you perhaps define what is meant by data observability, how it differs from traditional approaches to data quality and monitoring?
Yes, data observability is a new category of data management software. It's not just to do with data quality, though. Certainly, it's the ability to continuously monitor the health and usage of your data and the health of your data pipelines by collecting, if you like, signals from different layers of technology that are going to allow you to detect changes and incidents while those pipelines are executing, raise any kind of tickets about those incidents so that people can act on them, and then obviously to allow you to design and improve the resilience of your pipelines so they don't fail very often. And improve the overall performance. And if they're running in the cloud, also optimize the cost of executing those within the cloud. So ultimately, so that you're producing high quality, compliant data with good lineage. That you can understand how it was created. So I think the big difference with data observability is it's kind of real-time monitoring of what's going on in your data and your data pipelines as they execute.
Okay. And what are some of the most important features that data observability tooling provides?
Oh, that's a great question. Data observability features would have to include the ability to integrate with tools that are used to build the pipelines, for example, ETL tools, for example, or even notebooks where data scientists might create a pipeline in Python or R, for example. So they need to integrate with those to understand the original pipeline. Secondly, they need to integrate with execution engines. So for example, some data pipelines might run on Apache Spark, or they may run on a database like Snowflake or Google BigQuery or Presto, in which case, they need to integrate with those execution engines. And they also need to be able to observe the data being read by the pipeline and being written by the pipeline. So data observability platforms are often got what I would call agents, software agents that plug into all of these tools and execution engines and data stores to allow you to monitor what's going on as pipelines execute. And consolidate, if you like, all of the data coming back from those agents and analyzing it in real time to see if there's anything happening as the pipelines execute, but also to collect kind of historical data about what's going on in your pipeline so that you can go back and look at it over time and see if there's any pipeline problems happening on a regular basis, if there's any pattern to that. And also, I think as well, there's got to be some kind of integration with notification software to notify data engineers if there's problems with the pipelines. That could be something like as simple as Microsoft Teams or Slack or something like that, or they can notify them through those mechanisms. There should also be some kind of integration with popular help desk kind of software, or thinking something like Jira or ServiceNow or something like that, and perhaps also reports that are pre-built that allow engineers to look at and view what's going on in pipelines and any incidents being reported by data observability software. So there's quite a lot going on. I can kind of think of it like it's got connectors into a whole range of different software in order to be able to observe what's going on.
And in your opinion, why is data observability becoming increasingly important?
Oh, that's really because of the fact that we have moved away from centralized computing all those years ago with mainframes and whatnot, where everything executed in one place. Now we've got distributed execution. We're running in a distributed computing environment. We have data being generated at the edge. We have data in software as a service apps. We've got data in multiple clouds and on premises. We've got some processing happening on premises, some happening at the edge, some happening in the cloud. So the distributed, executing environment is far more complicated than it ever used to be. And so, with all of that going on, plus different execution engines, potentially managing the execution of even parts of a pipeline, the complexity around tracking what went wrong because of a failure is really difficult. And I think could take you a huge amount of time without data observability. So I think complexity is a main driver for this. I think also another reason why we're seeing it is we are moving into a world of real-time governance, and observability, I think, is stage one of that. Data observability is kind of the early onset of a new era in real-time data governance.
Okay. Well, mentioning data governance, how does data observability fit into the broader landscape of data management?
Absolutely, yeah. So I think it's an additional capability which is part of a governance framework that a company may wish to implement. So it's a new capability which is part of a governance program, in my opinion. It's designed to help you improve your pipelines and monitor things in real time, spot anomalies, allow you to improve the resilience of your pipeline so they don't fail. They can keep running even if there's a schema change, for example, that's detected. And also, so you don't miss anything. It could be that poor quality data is flowing through your pipeline, and you thought you had all the logic built into your pipeline to make sure that you fix it all, but maybe you don't. And so it's a good way to help make sure that your testing is robust and complete. So I think for sure it's part of a wider governance capability, and I think the trend will be that data observability will perhaps become part of a bigger piece of software. For example, data fabric. Whereas today we don't see data fabric really with data observability capabilities. We're seeing startups with this new capability, but I think ultimately it'll become part of a bigger data fabric platform that has the ability to govern data across a distributed data landscape from an end-to-end point of view.
Well, final question on this topic, Mike. What do you see as the biggest challenges when implementing data observability?
I think the biggest challenges for organizations are going to be to make sure the data observability software they're buying integrates with the tools they're using to build pipelines. And so that they don't end up with, let's say, some pipelines with observability and some not. what you'd really want to do here is to have comprehensive coverage from data observability. And if people are using different tools to build different pipelines, you've got to make sure that the software you're buying is going to be able to monitor all of the tools being used. I think it's especially important now that we are a lot of companies looking at data mesh, because as more data engineers start to build pipelines around your organization, um, there's more engineers, there's more tools, there's more pipelines, and therefore, we got to make sure that we're observing what's going on there across all of that in order to get a sort of standardized approach to being able to monitor and build up resiliency in the pipelines that you're creating, and to make sure that you don't end up with let's say, an ungoverned data engineering environment. So I think that's a big challenge. I think the other challenge is going to be integration with existing software, particularly data catalogs, because I think data catalogs are collecting what I would call data intelligence, sort of over time, and data observability is more about real time, and we kind of want both. And so if there's integration between data observability and data catalogs, I think it's a very, very useful thing, because lineage is often recorded in catalog, and observability needs lineage diagrams to show you where the problems in your pipelines are. So I think those are some of the biggest challenges. And I think also the other thing I would say is making sure that data observability doesn't just observe your execution environment, but also observes the design. What that means is your pipeline may be designed one way, but perhaps it's executing one of the ways through the pipeline, but perhaps what's supposed to happen is your pipeline has a specific route that it should follow, and maybe it's following a different route. The trouble is that some data observability products don't take notice of the design lineage, what I would call design lineage versus execution lineage. And I think that's a challenge. I would be wanting to make sure that's the case, and to also make sure that you've got integration across all of the execution engines and across all the tools you're using to build pipelines.
Okay, well, thank you very much, Mike.
Okay, Werner, thank you.